Great guys, welcome to this interesting discussion on some GMAT questions. This is Ankur and I'm gonna present to you a couple of interesting questions. Here is one question on GMAT. T equal to $6.8, A, B, 8. If A and B denote the 100 and the 1000 digits respectively of the sum of money T, what are the values of A and B? Statement 1. If T were rounded to the nearest cent, the result would be $6.85. Statement 2, if T were rounded to the nearest tenth of a cent, the result would be $6.85. Awesome, great guys. Interesting question. Let's take a look at the concepts which are involved. Always remember, GMAT is all about concepts and its application. So we are always going to take a look at the concepts and how to apply those concepts. So here's the concepts. So we need to know two things here. One is the concept of decimals and the rounding, and then the concept of the tenth and the 1/10 of a cent. Those two concepts. So let's start with the concept of rounding. When I say that there is a number called, let's say 123.245, first of all the question is what are the 10th place, what is the 100th place, units place, 10th place, etc. Okay. So let's first start and discuss that. Now, if you notice this 2 which I just highlighted, what place is this 2 in? Answer is, it is in the 10th place. Okay, and listen to my pronunciation carefully. It is the 10th place. So I'm ending my last two letters with TH, right? This number 4 is in which place? It is in the 100th place. Again, we are ending the last two letters with TH. So all the digits which come after decimal are, first comes the 10th place, then the 100th, then the 1000th, and so on. What about the digits in front of the decimal? We have 3 there, which is the units place, then we have 2 there, which is the tens place, then we have 1 there, which is in the hundreds place, and so on. I hope that this concept is very clear, which is in the units place, which is in the tens place, which is in the hundredth, and which is in the thousand. Now what about rounding? Simple concept. In rounding, we just look at the digit to the right of the digit that we are rounding. Okay, so suppose I am saying that, let's say this number we are going to round off, okay, to the 10th place, right? So what will that value become if I'm rounding it to the 10th place? So if I'm rounding to the 10th, which is this digit, I look at the digit to the right, which is 4. And the rule says if the digit to the right is less than 5, we do not touch it. Okay, so we are just gonna round this whole number to 123.2. Okay, if we are rounding it to the 10th. If we are rounding it to the 100th, we are gonna round it till this place, right? Now notice that to its right is 5, and the rule says that if the digit to the right is 5 or greater than 5, then we round it up. So the 4 we are gonna round it up to 5, right? Hope this is very clear. Rounding to the 10th, we look at the next place. If it's 5 or more, we round it up. If it's less than 5, we keep it as it is, and this rule applies to any digit, any place. Okay, so just let's try a few questions to make this clear. Here's your question. What would 125.354 be if it is rounded to the nearest tenth? So your answer is, since we are rounding it to the 10th, we are rounding it to the digit 3 there, and we look at the digit to its right, which is 5, and therefore it rounds off to 4, and hence the answer is 123.4. Great. Now take a look at this next question. What would 123.354 be if it is rounded to the nearest 100th? And now let's go to the 100th place, which is in this problem number 5, look to its right, which is 4, and since 4 is less than 5, we are going to leave it as it is, and therefore the answer is 123.35. Great. So hopefully you got those two right, and that clarifies the concept of decimals and rounding. Now, we in this problem also need to know a extension to this, a concept of rounding to cents and rounding to the nearest tenth of a cent, right? So what do these two things mean? Rounding to cents simply means that we are rounding it to the 100th place after the decimal place. So, going back to this example, we start with 123.245, we are rounding it to the nearest cent, which implies that we are rounding it to the nearest 100th. Look at the 100th place, which is 4, look to its right, which is 5, so we know we are going to round it up, and therefore the answer will be 123.25. Great. And now, rounding to the nearest tenth of a cent means 1/10 of a cent. So we are going to round it off to the 1000th digit after the decimal. Take a look. Here's your example. Let's say you are starting off with $123.2456. You are rounding it to the nearest tenth. So that means it implies we are rounding it to the 1000th. Look at the 1000th digit, which is 5. Look to its right, which is 6. Since 6 is greater than 5, we are gonna round it up, and it's gonna become 123.246. Hope this is crystal clear. And just a note that the reason for doing the above is that when we talk about rounding to cents, 100 cents make a dollar, and so when we round to cents, we are rounding it to the 100th place, and when we round to the 10th of a cent, we round to 1/10 of 100th, which is the 1000th place. Excellent. So now we know two critical concepts which are required for this question, and now we are in a position to handle this question. Let's look at the statement 1. Statement 1 says that t rounded to the nearest cent would be how much? $6.85. We know that nearest cent means that the statement 1, nearest cent, would imply, what would it imply? As we've discussed, that we are rounding it to the 100th. Great. So we are rounding to the 100th place, right? The whole number, we are going to round it to the 100th place. Look at the number. Which digit is in the 100th place? It is the digit A. If you are rounding it to A, we are going to look at the B, which is to its right, and depending on B, we are going to round A up or leave it as it is. But in this problem, we do not know anything about B. So we have two cases. One case is if B is less than 5, in which case I will not do any rounding up. I will leave A as 5 because originally also it was 5. But if B is greater than 5 or equal to 5, in that case I know that I'm going to round it up. So if A, I have to round it up and it becomes 5 over there, the original value of A has to be 4, so that on rounding up it will become 5. I hope that this is very, very clear. Okay, if you want, just spend a couple of seconds again on this logic. Basically, we've just applied the above concept of rounding and interpreted the sentence which says rounding to the nearest cent, which we have understood that it means it is rounding to the 100th place after the decimal. Great. Thus, from 1, what can we conclude? We are getting not a definite answer. We are getting A either equal to 4 or we are getting A equal to 5. So there are two options. Moreover, we do not get any idea about B at all. B could be anything. Hence, we say that the statement 1 is not sufficient to answer this question, because as you know from GMAT that a statement is sufficient only if we get a definite answer to the question. Great. So that takes care of the statement 1. Now time to look at the statement 2. What does statement 2 say? In statement 2, it talks about rounding to the nearest tenth of a cent. As we've discussed earlier, that means we are rounding to the nearest thousand. That's right. Now, statement 2, rounding to the nearest tenth. Okay, and therefore we imply that when we are rounding to the thousandth place, value is 6.85. Now, notice here that there is no digit in the thousandth place. Actually, that means that the digit is 0. Okay, notice that there is no digit, and if we are rounding to thousand, that means that we can put that digit as 0. Which in turn implies, now notice, if I want to get a 0, okay, and originally 0 in the thousandth place, so B I want to make it 0, and notice to its right is 8, which means that when I'm rounding to 1000, I have to round it up. Now what digit should it originally be if I have to round it up, and it has to become 0? The value has to be 9. Because only 9 when I round it up will become 10, which will then leave a 0 in this place, and the 1 will carry over to the 100th place. Add with 4 and you will get the result as 5 over there, right? Okay, so hope that's clear. We again just go back. Here you have 8 and we are rounding it to the 1000, which is B. B is becoming 0, and since B is becoming 0, I know that I have to round it up. So originally B must be 9. Okay, so only if B is 9, I will round it up. It will become 10, which will give me a 0 over there. But then when I get a 10, the 1 will carry over to the 100th place over there. 4 plus 1 will become 5, and here I will get the 5, and you will get 6.850. Now what does that imply? That this value has to be 6.8498, and if I compare that with the original, which was 6.8 AB8, I get a definite answer that A has to be 4 and B has to be 9. There is no other option possible, right? So this is the deduction and the conclusion. This is a very tricky one. Make sure that you got this very, very clearly, and that therefore implies that the statement 2 is sufficient alone by itself. Now, statement 1 was not sufficient. If you recollect, the statement 2 is sufficient. We can therefore conclude that the answer is B, which is the answer when statement 1 is an S, not sufficient, and statement 2 is sufficient, and hooray! This means we finally cracked this problem. What an amazing problem. Lot of concepts, lot of logical thinking, step by step analytical thinking, or classical GMAT problem. Now just to make sure that you really analyzed and got it, just try a couple of what if scenarios. Let's say, what if the statement 2 said this? If t were rounded to the nearest tenth of a cent, the answer is 6.852. Okay, now going back to the original, which says what? 6.8, what was the number? 6.8 AB8, and it is becoming 6.852 when I am rounding to the nearest tenth. Nearest tenth means the nearest tenth of a cent means the nearest thousandth place. Go to the thousandth place, it is B. B is going to be rounded up because to its right is 8.